Hi, in this tutorial we are going to learn how to detect objects using our own voice. You can add comments and ask for more ideas to my next videos. So let's first of all see our demo. Now let's show some images, for example this cat, and we will click the button again. Look for a cat. And you can see that the cat was detected and the person is no more detected. Let's change the image. You can see that the bus is not detected, and now let's ask the model to detect the bus. Look for the bus. And you can see that the bus is detected. So let's start coding and to figure out how it can be done. So first of all, let's create a conda environment. I will leave an instruction file in my GitHub repository that contains all the steps. So basically you can do a copy paste, but I will show each step so you can follow and compare it to your computer, to your process. Okay, so first of all we are going to create a conda environment. I will call it detect object by audio, and it will be based on Python 3.8. and now we will activate this new environment. Next we are going to install several Python libraries. You can see the list of the libraries. It will based on majorly on opencv, but we will use pandas and we will use sound device in order to record our audio, and also we are going to use sound file in order to convert the audio to the Google API requirements. We will use speech recognition in order to convert the audio to text, to extract the text from the audio. And then we will download several YOLO 4 tiny models, the CFG files and the weight files. The classes files will be in my repository, so you don't have to download. If you are going to use my GitHub repository, you can directly use these classes txt files. These files contains all the classes names. So this is the CFG file. Just download and rename it to a .cfg. This is the weight file. Download it as well. Copy it to your home directory, to your Python home directory, so it will be easier to find later. I will copy it to my detect by audio directory. Now we will learn how to capture images from the camera using opencv, a very straightforward process. If you are not familiar with opencv, you can follow this tutorial. If not, you can jump directly to the next step. So here are the three files: the classes, the CFG and the weights. So let's create a new Python file. We call it detect object by audio.py. Import CV2. Of course, don't forget to change it to your conda environment. I'm using the VS Code. If you're using another IDE, don't forget to change it to your new conda environment. Then we are going to use the video capture function of CV2. The 0 argument means that it is the first camera that will be found in this computer. Then we will define the weight and the height. 1080 1208 on 720. It's a common resolution. Most of the cameras has this kind of resolution. Let's run it just to see that we don't have any syntax error. Okay, and continue. Now we will create a while loop. It will be always true since it's capturing the images from the camera with the infinite loop. Of course, we will have to do a break if we are clicking a specific key. So we are going to use the cap.read in order to capture frames, and we will show these frames, and we will add a wait key in order to break the loop. So if the user will click the Q in the keyboard, the loop will be braked and we can exit this loop. Okay, let's run it, and we can see that the camera is working well. We are capturing the frames. Next, we are going to add a YOLO detector. We will use some CV2 functions. We will load the YOLO form model using a readNet function. This function needs two arguments. The first one is the weights, and the second one is the CFG file. We will copy the path to these files, and we will fix the backslash to slash. Next, we are going to create a model variable, a model instance, using the detection model, and we will send the argument of the net variable, and we are going to use a size of 416 on 416. This will be the input size of the images, and the scale will be divided to 255. So the model needs values between 0 and 1. Basically, any image has a value of pixel between 0 to 255, so we are normalizing the input. Now we are starting to detect objects. So we will create 3 variables of classes ID, scores, and boxes, and we are going to use the detect function. And first of all, let's print the return values of this detect function. The class ID is a numeric value of the class ID that being detected. The scores is the probability, and the B boxes is the position of a box inside our image. So let's run it. We will get a bunch of numbers, and next we are going to extract and figure out what is the meaning of each number. So let's loop inside these variables. We will use the zip function. Okay, first of all, we are going to draw a rectangle around each object that it's been detected, using the output of the bbox list. So we will extract the x, y, width, and height. And basically x and y's are the left upper corner. So first of all, let's print the output, and let's draw our rectangle using the rectangle function of CV2. We have to send several arguments. First of all, the frame, which is our frame, then the X and Y, which is the upper left position, and then we are going to add the width and the height to get the right down position of the for the rectangle, then the color and the width of the rectangle. Now let's run it and see the outcome. Okay, it detected me, I'm a person, and you can see on the log the X and the Y, the width and the height, and also it draws a rectangle around my my face. Now let's load the class's name so we can translate the numeric value of the class ID to a string. So we will use pandas in order to load our text file. We will use the read CSV function. We will send it our classes txt files. Our file doesn't have header, so the header argument will be none. And we would like that the column inside the data frame will be named classes name. So this is the syntax. Of course, pandas import pandas as PD. And now we are going to loop inside our data frame, and we would like to create a simple list so we can use it later. So we are extracting the class name using pandas function. And next we will use the append function for each of the classes. And let's print our class names, and you can see that it works fine. Let's break the process so we continue to the next step. Next, we are going to extract the name of the object from our list. Simple command. And then we would like to put this text inside our frame. So there is a put text function from CV2 library. We have to send several arguments: the frame, the text, the position of the text, the font, how the thickness of the font. You can read about it on the documentation or copy this command. Okay, let's run it. So now we can see a rectangle, and we also can see the text. You can see a person or a cell phone. So it works nice. Let's continue to the next phase. Now we would like to add a virtual button and give to this button a functionality. The functionality will be the ability to record our voice. So first of all, let's learn how to draw this button. This button basically is a rectangle, that a filled rectangle with a specific color. Let's add some variables like x1, x2, y1 and y2 that will be the position of this button, this filled rectangle. And now let's draw this rectangle. The same process as we did before, but now the color will fill the whole rectangle. We will use the -1 argument in order to fill the rectangle. And let's put the text inside this rectangle. We will call it click for record for 3 minutes. The same font, and we will the text will be in white color. Let's run it. We have an error, or we forgot an argument. The position of the text, of course. Let's run it again. Okay, you can see this is the button. Click for record, 3 seconds. Now let's add a functionality to this button. So we have to create a window and give a name for this window. It's very important that the name will be the same name in the show command that we used earlier, and we will add to this window a functionality of set mouse callback in order to capture the click of the mouse. We have to create a new function. We don't have it yet, so basically we will leave this part empty, and let's create a function that capture the left click of the mouse, and also this function will record our audio after we are clicking the left button of the mouse. We call this function record audio by mouse. Inside the function we are going to check if the left button of the mouse was pressed, and if it was pressed, then we would like to print the position of the mouse on our window. That means the X position and the Y position. Now we can copy the name of the function and send it to our set mouse callback, and let's run it. Now we are clicking the mouse and it's not working. I believe that the problem is the name of the window. It should be the same name. So here it's a frame with the uppercase in the F, and here is the I'm show has an argument of a frame with the lowercase, so we'll do it with uppercase. Now they are in the same name, and let's try it again. Okay, it's working. So you can see that each time I'm clicking with the left mouse, it's print the position of the mouse, the X and the Y. You can see it on the log of the Python log. Nice, it's working. So let's continue for the next step. The next step, that we would like to double check that if the mouse was clicked inside the button, and in order to do this, we will check if our X variable is between X1 and X2, and the Y variable is between Y1 and Y2, which are the position of our button. And we will print to the log if we are inside the button. Okay. Okay, please notice I'm clicking outside the button and inside the button, and when I'm clicking inside the button, it prints click inside the button. Okay, it works fine. Let's continue for the next step. Now we would like to create a Boolean flag to know if we are clicking inside the button or outside the button. In order to use this flag in other functions, we will create it globally. And first of all, we will create as a false as its default. And now we are checking if it's false, we will change it to true, and of course if we click outside, we will change it back to false. Now we would like to show our rectangle and the text only if the button flag is true. That means only if we pressed the left mouse. Okay, let's continue to the next step. We would like to record our voice and then extract the text from our voice in order to figure out what we have, what we speak in the microphone. So let's import the sound device as SD. This is for record our voice. We also need the function write in order to write it to our disk about our audio. And we will need NumPy to do some conversion to the audio. Let's also import sound file in order to do a convert to our audio file. I will explain it later. And also import the speech recognition, the Google speech recognition. And we will use it to extract the text from our audio. Let's add some more variables, the frame rate and the duration of the record. We will use it for 3 seconds, and let's also define the file path. Okay, this is the record function, and this is the arguments. This will help us to record our voice. Channels means that it will be stereo, right and left. Now we will wait several seconds, and we will write our record to a file. Let's try it. The outcome is a WAV file in my temp directory. You cannot hear the file, but you probably, if you follow this tutorial, we will create your own file. So now let's continue to the next step. In order to extract the text from the audio, we need to convert our audio file to a PCM file. And we will create a function that do this process. We call it a get text from audio. We are using the sound file library, reading our saved file, and we are write it in a new file, but we are convert it to a PCM file. Now let's recognize the text inside our file. We are going to use the Google API, the speech recognition API. First we are creating an object, a recognizer object. Next we will load our new file. It will be our source. And the next step is recognizing this audio, this source. The result variable will be the outcome of this process. It will be a string that contains the text of the record. Let's print it. And of course this function will return this text. Let's launch this function from here and run it. So after this process was finished and we are recording our voice, let's add another variable. We call it look for the class name. Basically it will be the text that was extracted from our audio. It also will be a global variable. And another thing, sorry that you couldn't hear my voice in the previous minute. Trust me, it worked fine. Now we will check if our object was mentioned in our microphone. That means that we would like to display the rectangle and display its text. So you can see that I'm adding it to our function and now it's ready. Okay, let's test it. Okay, let's click the button and look for a person. Look for a person. No, let's try again. Look for a person. Okay, a person is being detected. We can see the rectangle. We also see here the text. Let's go back to the image and let's try another one. I have on my phone images. Okay, this is an image of a cat and we will ask it to look for the cat. Look for the cat. And the cat is being detected. Let's try another image. Look for the bus. The bus is being detected. Please notice that if I'm changing the image, changing the picture, it stops detecting because it's not a bus. Let's go back to the bus and the bus is being detected. Look for a chair. Nice. Another try. Look for a bicycle. Very nice. Thank you very much. I hope you enjoyed my tutorial. See you soon.